we are going to skip ahead a little bit to section 6.6 in the textbook. This is the chapter on improper integrals. Now, to motivate this, I want to look at the graphs of two different functions. So here on Desmos in green, I have graphed f1 of x is the function 1 divided by x. And in purple, I've got f2 of x is 1 divided by x squared. And, you know, they look reasonably similar. One of them is even, one of them is odd. They've both got this asymptote. They both sort of flatten out as we go. But the purple graph, the one on x squared, seems to flatten out a bit faster. Now, let's just look at the graph of 1 divided by x. And in my formula 3 here, I've asked Desmos to calculate what is the integral from x equals 1 up to b of the function f1 of x dx. And right now my b equals 1. So Desmos tells me that is 0. Hey, thank you. I really needed to know that the integral from 1 to 1 of this function is 0. Don't think about it too hard. Now, I've left b here as a slider, so I can move it over. And I actually have my equation 5 here is highlighting the area that this integral represents. So right now I've got b equals 2. The value of this integral will be 0.69314 and so on. And that's exactly how much area is shaded in blue here. Now, all the integrals in this chapter are concerning what happens to integrals when we have to get infinity involved in different ways. So the question is, can I continue to move my slider out and continue to get larger and larger area here? Yes, I can. But what do I make of that? So as my slider goes out farther and farther, I see that the value of this integral increases. Yeah, that makes sense. I've got more area. But as I go, so here I've got an integral that's larger than 2, larger than 3, larger than 4. It seems to be slowing down a bit, and actually it has gotten outside of my window here, so I would have to zoom out a bit. So at this scale, this is 4 units of area that's been shaded in. If I continue moving my b out, okay, it's settled down to maybe 4.5, but has actually stopped. I only have my b here as b equals 100. Could I put in b equals 1,000? What do I get then? My area is still increasing. Is there some value I can give this area for integrating across the whole real number line? Now, it's a bit of a loaded question because you see I'm only starting my integral at x equals 1. I don't know quite what to do with this infinite area up top here, at least not yet. We'll get to that soon enough. But I've got a limiting process here. Remember limits from Calc 1. My x is getting larger and larger and larger. And I want to know if the value of this integral, excuse me, my b is getting larger and larger and larger. And I want to know if this integral is going to settle to some limiting value or not.